Hi, everyone. My name is Thiara Ortiz. I'm a staff CDN reliability engineer at Netflix, and I'm super excited to talk to you all about achieving excellence, how we define thresholds that transform service quality. Now, episode 1, what's an SLO? So let's get into some of the definitions before I go into the details. So before I start talking about SLO thresholds, I figured I'd take a moment to define what an SLI is and what an SLO. These are both defined extensively in Google's Site Reliability Engineering book, How Google Runs Production Systems. In short, an SLI is a service level indicator that is a quantitative measure of an aspect of a service. For example, if you're running a website, an SLI may be the request latency. In addition to that, we have service levels objectives, which are target range of values for a service. So if we're responsible for running a website, our SLO may be that we would want this request latency to be under 50 milliseconds. When it comes to SLOs, we can define them as a range of thresholds, so you may want to say something like, it could be between 10 and 50 milliseconds. You may want to have a lower bound to this, where you would say, I'd like my request latency to be above 2 milliseconds, providing you with some flexibility around your SLOs. So I'm a CDN reliability engineer at Netflix, and for those who may not know, OpenConnect is Netflix's own CDN, or content delivery network. The purpose of OpenConnect is to provide our members with the best quality of experience possible. We do this by partnering with internet service providers from around the world and bring our servers closer to our end users. We serve 100% of the streaming bits from our own CDN. So this map that I have shown here is a visualization of where we've located all of our OpenConnect appliances. And these servers are placed in both internet exchanges and installed in ISP's own data centers. So all of the dots in red are locations where we've launched them at internet exchanges, and all of the dots in white are where we've deployed them within ISP networks. To put this into perspective, we're serving over 230 million members in over 175 different countries, and we have over 18,000 of these OCAs. Now, for those who may be wondering, where does the CDN fit in? I kind of wanted to walk through what the playback experience is for our members. And if you ever have a system design question around this, it'll give you a good idea. So let's say you're sitting down on your couch and you hit that play button. You're wanting to watch, let's say, the first episode of Stranger Things. You have your client device, and this device makes a request for something known as a playback manifest. It's effectively the instructions that the device needs in order to play back the content. It ends up talking to our Netflix services, which are hosted in the cloud. It reaches some playback application service, which is responsible for determining which files make up this playback, and it ultimately assembles the manifest. This playback app service needs to know exactly which OCA should be serving this particular request. In order to do this, it leverages something known as the steering service, internally referred to as CODA. And CODA is responsible for figuring out which is the best OCAs for this particular request, and it generates the URLs corresponding to them. Now, the steering service request needs to know which OCAs are out there in the world that have this particular content. So it fetches this from something called the Cache Control Service, or CCS. On a periodic basis, every single one of our OCAs from around the world are periodically phoning back home, giving insights as to their availability, the files that they have, and their BGP advertisements. This all gets fed into the Cache Control Service, rolled up into the steering service, and then handed back to the client. And at this point, your client or your TV has the URLs that it needs to stream Netflix. And from there, they can go ahead and start streaming the content. That's basically how it works, how Netflix CDN streaming happens. Now, this purpose of the conversation is to go over SLIs and SLOs, so let me just highlight a few of them that we would want to track here. So for all of the OCAs that are reporting back home, trying to report data, we would want to know the error rates at which they're unable to successfully post this data. Our SLI may be the error rates, and the SLO is our target. So perhaps we're trying to target errors to be under 0.05%. Another thing we would want to monitor is the time to URL generation. And so this would be our SLI, and our SLO would be that we would want a duration under X milliseconds. Now, what I'm going to focus on today and give you some more insights on is this whole idea of quality of experience. So when a client is successfully streaming from our OpenConnect appliance, what is the overall quality? And that gets us into episode 2, quality of experience. And for OpenConnect and as a CDN SRE, I fundamentally want to know how well we're delivering the content beyond just like, did the client get an error or did we get non-200 status codes? And as part of that, let me go over what quality of experience means. So quality of experience is a measure of satisfaction with the telecommunication service. It is supposed to capture the whole experience for a member. And for today's conversation, I'm going to be focusing on the metrics that we would monitor that encompass the user experience during playback. Now, how many of you have ever tried to stream content from a streaming service and attempted to play a piece of content that took way too long to buffer up? I'd imagine nearly all of you. And I personally find this the most frustrating when, let's say I'm trying to watch a 30-second piece of content and I'm stuck waiting for it for over 30 seconds. Oftentimes I'll just abort and it won't even be worth my time. And it's not a great user experience. So this concept of waiting before getting the first piece of content is known as play delay. How long did it take between hitting play and getting the content? Our consumer insights team has done research and has shown that higher play delays correlate with a worsening rating for our streaming service. And given that we're our CDN, we can directly influence this. And so the better we can minimize play delay, the higher user satisfaction that we get. So that covers the first one, play delay. Now let's move on to number 2. Have you ever been in the middle of watching an episode and then you get that terrible spinning rebuffer symbol? It's quite terrible. Back in 2021, when the world was enamored by Squid Games, it would have been terrible if you were on the first episode, unsure if the main character was going to live and die, and then you suddenly got this rebuffer symbol. Absolutely terrible. At Netflix, we're able to classify our rebuffers in 2 ways, but the way that OpenConnect is particularly interested in is network rebuffers, which is when the client encounters the spinning rebuffer symbol as a result of not having the correct network capabilities to keep up. And again, we're the CDN, so we can directly influence this. We're trying to minimize the distance that our clients are having to go to fetch the content, and ultimately we're wanting to minimize the congestion that they would have on their network. All right, so number 2 is this network rebuffers. Let's talk about number 3. So I'm going to show you 2 pieces of video that are roughly of the same content to explain the last quality of experience metric. So let's say that this is a piece of content that you would expect from your Netflix premium account. You can kind of see some crisp edges in this Wednesday Addams prom scene. Now let me show you another video, roughly the same thing. But as you can see here, there's a ton more encoding artifacts. It's not as visually as appealing. Now, on our devices, we have software that's running that is attempting to minimize the frequency of network rebuffers. When it detects that its network isn't able to keep up at the current bit rates, it will automatically downgrade the bit rates, resulting in lower streaming quality as a result. Again, OpenConnect is directly influencing the outcome of our members' experience, and so this is something that we're monitoring, which is the relative bit rates during playback. So to summarize, within Netflix and our playback experience, we have our 3 QoE metrics. So we collect data on play delay, we collect network rebuffer frequencies, and the frequency at which our clients were reducing their bit rates. Now, as mentioned earlier that there's some software running on the devices, this software is actually known as the adaptive streaming engine. And in many ways, you can think of this ASE as being kind of like these pick 2 memes, where this adaptive streaming engine is having to make the proper trade-offs. If it wants to reduce the play delay, it may be incurring a higher frequency of network rebuffers, or it may be having to reduce the bit rates as a result. And so there's periodic trade-offs that are happening as a result of the adaptive streaming engine. Okay, so let's get into episode 3, how we're gonna actually define thresholds for our quality of experience SLOs. Now, I thought of a few different ways in which we could define thresholds that vary in levels of complexity. And I figured I'd go through the most easiest solution and then go on to the more complicated ones. And with that, let's talk about what I've defined as our level 1 method. Might be a little obvious, but we could leverage our own intuition to determine what thresholds that we would want to set. So typically, these are better for defining the worst examples of it, but let's say I wanted to define an SLO threshold for our play delay metric. I may personally say that 15 seconds is way too long for someone to be waiting. The benefit of defining our own SLO is that we can set the upper thresholds of what shouldn't be expected on the platform. It's relatively easy and low cost to implement. However, the con is that it's not a good threshold for sensitive applications. And not only that, I'm a CDN reliability engineer, so my sensitivity to these things may be very different from people actually experiencing the service, their personal thresholds. And with that, we'll move on to level 2, which is the next level of complexity. Now, typically when it comes to our SLIs, we have a time series view of this data. So this graph is looking at time series view of our normalized bit rate over time. And we can begin asking ourselves, what does the past tell me about the current capabilities of my service? Now, what we may be able to do is we could take the historical data and start learning from the distribution. If we were to take this time series view and then plot it as a box plot, we could start examining the maximum, the upper quartile, the median, the lower quartile, and the minimum, giving you an idea of what the distribution of the data is. Now, when it comes to creating these visualizations, it's relatively straightforward. If you're able to import them into pandas and drop them into a data frame, it's a single line of code to be able to visualize this data. Now, with this information in a box plot and assuming a normal distribution, we can start detecting what may be a statistical outlier and a potential good threshold for our SLO. An outlier is defined as a point that is significantly different from the data set. To compute this, we take the inner quartile range, which is the difference between the upper quartile and the lower quartile, and we set the thresholds as the upper quartile plus 1.5 the inner quartile range, or we take the lower quartile and subtract 1.5 times the inner quartile range. Now let me walk through an example of this. So let's say we took our time series view, the one I had initially shown of the normalized bit rate, and we were to plot it as a box plot. Now we have this distribution being represented here. Typically, we're wanting to know when our service has degraded, and so we would want to set our potential SLO to be when the data falls out below the expected value. Our potential SLO could be defined as the lower quartile subtracted by 1.5 times the inner quartile range. And doing some math here, we may be able to set our potential SLO to be 87.5%. I do want to make a few call outs though. So at my time at Netflix, a few things that I've found is that when we see global movements in our data, it may be a result of other things that are happening underneath the hood. And so if we were to take that normalized bit rate chart that I had shown earlier and split it by the different devices that we serve, you can see that there's different trends across different devices. And so we may want to consider the factors that make up the aggregated view, and we may want to consider the differences in device mixtures when we're looking at a global SLO. And when it comes to this, we can oftentimes fall victims to Simpson's paradox, which is a phenomenon in statistics when a trend appears in several groups but disappears when we aggregate the data. And as you can see here, there's this really nice minute physics video, but the gist of it is when we're designing our SLOs, we need to make sure that we're understanding how the mixture of clients can influence whether or not we would trigger our alert. And so in some cases, when it's as egregious as this, we would want to break out our SLOs and the specific thresholds to be per group basis. So we would want to define an SLO for this blue group and this orange group. Not only that, I've also learned quite a bit that oftentimes we're talking about defining SLOs when we've had an incident that was uncaught due to a non-existing alert, or perhaps the alert wasn't tuned well enough. And so when we're reviewing some of these data points and we're wanting to inform our potential thresholds, we would want to revisit some of these past incidents to make sure that they would have caught the regression. And so that covers level 2. Now let's talk about level 3. We can implement surveys. So I'm going to do a quick survey right now. And so we're all here in the group going to think that we're watching our favorite streaming service, Netflix. And I'm going to have this demo by having everyone start with their hand raised, and you're going to leave it up until I tell you to put it down. So we'll go through the group exercise. Okay, great. Now let's say you're watching Netflix and you encounter a single rebuffer. If that's enough for you to stop watching, lower your hand. What about 2 rebuffers? How about 3? How about 4? Woo! So basically at 4, I'll stop here. Basically at 4, there was 2 hands left. Now, yeah, so basically at 4, there was 2 hands left. And so what we can learn from this data is we can start looking at the cumulative distribution function, which describes the probability at which a random variable takes on a value less than or equal to a specific value. It provides a complete description of the distribution. So I showed you earlier a box plot. And here's the box plot of our survey data. I read the future. So as you can see here, a vast majority of people were feeling really sensitive at 2 and 3 rebuffers. And if we were to take this box plot visualization and throw it into a CDF, you can see here, this is the probability in which someone would have reported that they quit. And from this, we may want to set our thresholds to either 2 or 3 rebuffers. A vast majority of the audience had had their hand down by then. And so definitely something informative for us to look at. Now, there's a few things that are really beneficial about conducting surveys. The pro is that they're relatively lightweight. The con, however, is that I'm at SREcon with a whole bunch of people who really care about reliability and are perhaps really sensitive to network rebuffers. And so ultimately, my data points can be heavily skewed by the population we're polling. Not only that, if I wanted to get even more data, it would become unmanageable. It'd be harder to ask 1,000 people or maybe 2,000 people. So I needed some sort of scalable mechanism in order to be able to survey folks. And that's where I get into leveraging in-app surveys. So over the last year, Netflix has started launching cloud games in a few different countries. And what we've started to ask our members to fill out is a survey at the end of gameplay. We allow for them to tell us whether they thought their session was between 1 through 5. And we also give them an opportunity to select where we can improve on. So either the visual quality or even audio and things like that. Not only that, we also provide our members with a way for them to write feedback to us in a free-form feedback box. Now, with this in-app survey, we can start looking at potential SLIs that we would want to be monitoring, and we can look at how they change the impact of the survey rating. From this data, we can say that, hey, there's actually 2 points of interest here. On the lower end, it seems like anything worse on this SLI metric results in a worsening survey outcome, and anything above the one on the right-hand side indicates that they're gonna report a higher survey score. So that helps us influence what we wanna set our thresholds to. Now, this wouldn't be a talk with it 2024 if I didn't reference how we could take some of the survey data, feed it into an LLM to gain insights as to what metrics strongly correlate with specific user complaints, but it's definitely something that we can do. Now, there's a few pros and cons regarding the solution. The pro is that we can actually ask our members from around the world in different countries what their experience was like, and we can start correlating them to their different quality of experience metrics. The con, however, is that people's rating of a service may not actually correlate too strongly with their behavior. Now, we can leverage something even better than this. We can start doing some A/B tests. And so let's say we're trying to define SLO thresholds for something like a commerce site that has direct impact to revenue. What we may want to do is define 2 groups, one which is the control and one that is the treatment. What we end up doing is making the change on the treatment and then observing the QOE results or the revenue generation, compare and analyze the results to determine their level of sensitivity. Now, the pro of this is that it gives us diverse conditions with real users in the production system, and it actually gives you an indication of how that impacts their user experience and their behavior ultimately. Now, we've learned how we can define the thresholds for these SLIs to make them into SLOs, but let's talk about episode 4, which is how we're gonna actually action on these alerts. Now, this is looking at our normalized bit rate over time. And with this information, we can start tracking the network changes between the client and one of our Open Connect appliances. As you can see on the graph, there are several clients that typically report similar normalized bit rates, but at some point in time, roughly January 10th, we're seeing a drop in one of them. When we set the proper SLO thresholds, we're able to detect these changes, and we typically reach out to internet service providers to notify them of this degradation. Oftentimes, ISP don't know that they have this regression on their clients, and sometimes they're even unaware that their clients are experiencing these problems. So by working with ISPs directly and proactively identifying degraded machinery or connections, we're able to ensure that our members have the best viewing experience possible. And ultimately, ISPs want to work with us. So being a Netflix employee, it's actually quite great. Our ISPs actively are monitoring how well they rank up in this ISP leaderboard. So this ISP Speed Index, which is available in over 61 countries and regions, compares the normalized prime time average bit rates. And when an ISP has networks that are performant, it will be represented in the ISP Speed Index. And if the ISP is congested during prime time, we'll also have that available. And with that, let's get into the takeaway here. So ultimately, SREs are incredibly impactful to the end product. We're delivering content to millions and millions of people. And I understand that it can be really challenging to take time to learn basic statistical concepts, but what I'd say is having a high-level understanding of how this works becomes a superpower in that you can set up better alerting and spend less time debugging customer complaints. And from my personal experience, I've had a ton of luck watching open source videos and watching things like Khan Academy that I'd highly recommend trying some of these things out and seeing how well they work for you. With that, thank you.